Welcome to the Caution and Warning Systems lesson in the PMDG 737 Next Generation Groundwork from Angle of Attack. There are many systems on the aircraft that could be covered under the Caution and Warning banner, and we've devoted full lessons to some of the bigger ones. We will run through the comprehensive list of topics now, and then we'll single out the ones that we'll be covering in this lesson. Caution and warning systems on the aircraft include the Fire Warning and Master Caution System, the Mach Airspeed Warning System, Stall Warning System, Cabin Altitude Warnings, Aircraft Configuration Warning and the PSEU or Proximity Switch Electronic Unit, Altitude Alerting System, Auto Land Advisory Messages, Ground Proximity Warning System or GPWS, and TCAS, Traffic Alert and Collision Avoidance System. Fire protection systems and their associated warnings, GPWS and TCAS, all have lessons dedicated specifically to them. The cabin altitude warnings are very much related to the pressurization system, so we're included in that lesson. The altitude alerting system is dependent on the altitude set in the mode control panel altitude window, so that is included in the autopilot flight director system lesson. There are of course other warnings, such as the autopilot and auto throttle disconnect warnings, that are discussed in their relevant lessons. So with all of that in mind, let's run through what we'll be covering in this lesson. We'll start with an overview of the caution and warning philosophy on the 737 Next Generation. Then we'll talk about the Master Caution System, the Mach Airspeed Warning System, the Stall Warning System, and Aircraft Configuration Warnings and the PSEU, which stands for Proximity Switch Electronic Unit. The 737 gives oral, tactile, and visual signals to alert the flight crew to conditions that require action or caution while operating the aircraft. The nature of the signals provided varies depending on the degree of urgency and the nature of the hazards involved. Oral, tactile, and visual signals may be given simultaneously to provide both immediate warnings and further information regarding the nature of the condition. The 737 Next Generation does not use ICAS. ICAS is an integrated system which consolidates engine and subsystem information onto a single display or a pair of displays. It provides a centrally located alerting message display, usually on the inboard display units. ICAS stands for Engine Indication and Crew Alerting System, and we're concerned with the Crew Alerting System part of the acronym for the moment. The 737NG's Crew Alerting System consists of annunciator lights spread throughout the flight deck and centers around Master Caution and annunciator light panels on the glare shield. Unlike aircraft such as the 747-400 and the 777, the majority of alerts are not located on the upper or lower display units. These are reserved for engine indications and a small amount of other system information. The 737, like many other airliners, is based around a dark cockpit philosophy. This means that system annunciator lights in the cockpit should be extinguished while those systems are functioning normally. Logically, this means that lights will only illuminate when there is reason to draw crew attention to that system. This reduces distractions during normal operation and draws immediate attention to conditions which must be addressed. Different colors are reserved for different categories of conditions on the 737 flight deck. Red warning lights indicate conditions which require the immediate attention of the flight crew. Such lights include engine, wheel well, cargo or APU fires, autopilot or auto throttle disconnects, and landing gear unsafe conditions. Amber caution lights indicate conditions which require timely but not necessarily urgent attention of the flight crew, and there are amber caution lights scattered throughout the flight deck. Blue lights are for information and do not require immediate flight crew action. They inform the flight crew of electrical power availability, valve position, equipment status, and flight attendant or ground communications. Some blue system lights also indicate valve or component transit by illuminating bright, and bright illumination may also indicate a disagreement between switch and valve position. Green lights on the 737 flight deck indicate validity, such as landing gear and leading edge device extension lights, the speed brake armed light, valid squib tests, window heat on lights, and pressurization system modes. The 737NG flight deck has its roots in the original Boeing 737s of the 1960s, and it shows. The 737 was the first Boeing jet airliner to be designed without a flight engineer, and the master caution system was developed to ease pilot workload. The system is centered around the master caution and system annunciator lights on the outboard ends of the glare shield. The master fire warning lights located outboard of the master caution lights are separate to this system and are covered in the fire protection lesson. There is one master caution light at each end of the glare shield. Inboard of each master caution light is a system annunciator panel, and each system annunciator panel has 6 separate lights, each corresponding to a specific system on the aircraft. The system annunciator panels only include those systems located on the forward overhead panel, the aft overhead panel, and the overheat and fire protection panel. Not one light on the forward panel will trigger a master caution. The master caution system places attention-getting lights directly in front of the pilot's eyes for systems outside of their normal fields of vision. Once attention has been drawn to the illuminated light on the glare shield, the pilot then looks at the corresponding system panel elsewhere in the cockpit to diagnose the problem. We will run through the 6 individual system lights on the captain's annunciator panel and match them to the sections of the flight deck that they correspond to. The flight control light illuminates when any of the 10 amber lights on the flight control panel illuminate. The IRS light illuminates when any of the 7 amber lights on the IRS mode selector unit illuminate. And note that the GPS light will not be present here on aircraft that are not GPS equipped. The fuel light illuminates when any of the 8 amber lights on the fuel panel illuminate. The electrical light illuminates when any of the 10 amber lights on the various electrical panels on the forward overhead panel illuminate. The APU light illuminates when any of the 3 lights on the APU panel illuminate, and the overheat detector light illuminates when the APU detector INOP, or either of the 2 engine overheat lights on the overheat fire protection panel illuminate. The lights are laid out on each system annunciator panel to reflect where the relevant indications are laid out on the overhead panels. It's not entirely accurate, but it's generally correct and it helps the initial prompt of where to look on the overhead. Moving across to the first officer's system annunciator panel, let's run through each system annunciator light and point out the related lights on the overhead panel. The anti-ice light illuminates when any of the 14 amber lights on the window heat and various anti-ice panels on the forward overhead panel illuminate. The hydraulic light illuminates when any of the 6 amber lights on the hydraulic panel illuminate. The doors light illuminates when any of the exterior door annunciator lights illuminate on the forward overhead panel, and the number of lights here varies of course depending on the aircraft variant. The Dash 800 has 4 overwing exits for example, while the Dash 700 has only 2. The engine light illuminates when either of the 2 reverser or engine control lights on the aft overhead panel illuminate. It is also triggered by the electronic engine control reverting to alternate mode. The air conditioning light illuminates when any of the 12 amber lights on the air conditioning and cabin pressurization panels illuminate. The layout of these panels is slightly different on the Dash 600 and Dash 700, but it is still the case that the illumination of any one of them will trigger the air conditioning light. The overhead light is triggered by several lights on both the forward and the aft overhead panels. The PSEU, passenger oxygen on, and flight recorder off lights on the aft overhead panel all trigger the overhead annunciator light. It is also triggered by the equipment cooling off and emergency exit lights not armed lights on the forward overhead panel. For aircraft so equipped, the ELT and lavatory smoke lights will also trigger the overhead annunciator light. So that's all of the system annunciator panel lights covered now, and you can see that almost every single amber light on the flight deck is covered by this system. Many of those excluded are on the forward panel, where they would be within the crew's normal visual scan anyway. Also excluded are 4 of the amber lights on the overheat fire protection panel. The fault, APU bottle discharge, and the left and right engine bottle discharge lights will not trigger a master caution. The detector fault light on the cargo fire panel is also excluded from the system. So, to reaffirm which lights do trigger a master caution, all amber lights on the forward and aft overhead panels will trigger a master caution, and the engine 1 and 2 overheat and APU detector in-op lights on the overheat fire protection panel will also trigger a master caution. Whenever any one of the system annunciator panel lights illuminates, the master caution lights will also illuminate. As we said before, the master caution system is for all intents and purposes an attention getter that directs crew attention towards the problem area concerned. Pushing either master caution light extinguishes both master caution lights, and any system annunciator panel lights are illuminated. This resets the system for future master caution conditions. The master caution lights should not be left on for any longer than necessary, as they get very hot, and excessive heat can damage the lenses. Pushing and holding a system annunciator panel causes all of the system annunciator lights to illuminate on both panels. Upon release, the annunciator lights that remain illuminated show systems which have faults. This is called a recall, as it recalls any faults which were extinguished earlier when the master caution light was pushed. The master caution system is archaic by the standards of ICAS, ECAM, and other modern equivalents, but it does the job and can be very effective if used and understood correctly. The Mach airspeed warning system provides an oral warning when the aircraft exceeds maximum operating speed. This speed is 340 knots up to 26,000 feet, and Mach 0.82 thereafter. This is indicated by the red and black bars on the PFD speed tape. Maximum operating speed is referred to as VMO when the reference speed is in knots, and MMO when the reference speed is a Mach number. The Mach airspeed warning system is fed the overspeed warning signal by the left and right adderus. The Mach airspeed warning test switches on the aft overhead panel test the overspeed warning circuits. A successful test will sound the overspeed clacker. The number 1 switch tests the overspeed warning circuits in the left adderu, and the number 2 switch tests the overspeed warning circuits in the right adderu. The test is inhibited in the air. So to summarize, the clacker sounds in the air when the aircraft exceeds maximum operating speed, which is 340 knots up to 26,000 feet, and Mach 0.82 thereafter. Stall warning system. A stall is an aerodynamic condition where the angle of attack of the wing is increased so much that airflow over its upper surface starts to separate. In this condition, there is no longer adequate lift to maintain flight, so the aircraft starts to fall from the sky. As the airflow begins to separate, a phenomenon called stall buffet can be felt. This shakes the airframe and is a clear indicator of the onset of a stall. In some aircraft, however, the margin between stall buffet and the actual stall itself is too small to provide adequate warning. To provide adequate warning, many aircraft have an artificial stall warning device called a stick shaker. The 737 has one stick shaker on each control column. The stick shaker is effectively a motor with an unbalanced weight attached that is triggered as the aircraft approaches the stall. The stick shakers are triggered as the airspeed decreases below the top of the red and black minimum speed bars on the speed tape. The motors shake the stick, generating a lot of noise and giving a very clear tactile warning to the pilots. Either stick shaker will vibrate both control columns through interconnects beneath the cockpit floor. The stall warning system is deactivated on the ground, but armed at all times in flight. Additionally to activating a stick shaker, The stall warning system also increases control column field forces to discourage the pilot from aggravating the stall. The flight control computers also command nose-down trim on the horizontal stabilizer. The auto-slat system provides a further layer of protection, and we cover all of these in the flight controls lessons. There are two stall management yaw damper computers which independently determine when stall warning is required. They do this based upon air-ground sensing, ADIRU speed outputs, FMC outputs, alpha vane angle of attack outputs, anti-eye system usage, wing configuration, and thrust setting. The stall management yaw damper computers provide outputs to many systems on the aircraft. Most notably in this case, the stick shakers and the pitch limit indicator, or PLI, and the minimum speed bars on the PFD speed tape. There are two stall warning test switches on the aft overhead panel, which test their respective stall management yaw damper computers. The number 1 computer shakes the captain's control column, and the number 2 computer shakes the first officer's control column, and this test is inhibited while the aircraft is airborne. So finally, to summarize the most important point, the stick shakers are triggered as airspeed decreases below the top of the red and black minimum speed bars on the speed tape. Corrective action must then be made immediately to avoid stalling. Aircraft configuration warnings and the PSEU. PSEU stands for Proximity Switch Electronic Unit. Each landing gear strut has two air-ground sensors that monitor compression of the landing gear strut to determine whether the aircraft is in the air or on the ground. When the struts are compressed, the sensors transmit a ground signal, and when the struts are uncompressed, the sensors transmit an air signal. The Proximity Switch Electronic Unit processes the signals from the air-ground sensors and forwards them to various other aircraft systems. The PSEU controls 6 aircraft systems and provides discrete outputs for many more. The PSEU controls the following 6 systems: air-ground relays, door warnings, the speed brake deployed indication, landing gear transfer valve, landing gear position indication and warning, and takeoff configuration warnings. The latter two are the functions that we're concerned with here, and we will run through them shortly. There is a PSEU light on the aft overhead panel that illuminates when the PSEU has identified a no dispatch fault. A no dispatch type fault is one that prohibits the aircraft from departing. The PSEU light assists pilots and engineers in identifying and isolating faults in the various systems that the PSEU monitors and controls. The light is inhibited from the point that thrust is set for takeoff to 30 seconds after landing. Mentioning the PSEU in this lesson is only scratching a surface of a tremendously complex ecosystem of relays, sensors and components that are well beyond the scope of what we need to cover here. The PSEU interfaces with a great many systems and components across the aircraft, so we are only mentioning it here in the context of aircraft configuration warnings. The takeoff configuration warning alerts the flight crew to various conditions which might preclude a safe takeoff. An intermittent horn sounds if the thrust levers are advanced for takeoff, but the aircraft is not correctly configured. Any one of the following conditions will trigger the takeoff configuration warning. Trailing edge flaps are not in the flaps 1 through 25 takeoff range, or in a skew or asymmetry position, or have uncommanded motion. Leading edge flaps and slats are not extended or have uncommanded motion. The speed brake lever is not in the down position. The spoiler control valve is open. Stabilizer trim is not in the takeoff range, or if the parking brake is set. If all of these conditions have been addressed by the time thrust is set for takeoff, the configuration warning should not sound. Many fatal accidents have occurred where aircraft have not been configured for takeoff, even with a configuration warning system fitted. In 2005, a 737-200 crashed shortly after takeoff in Indonesia, due in part to the crew's failure to set takeoff flaps. The accident investigation established that takeoff warning was likely inoperative. In 2008, an MD-82 crashed shortly after takeoff in Madrid, Spain, also due in part to failure to set takeoff flaps. The takeoff configuration warning also failed to sound in the run-up to this accident. Many more accidents involving a host of different aircraft types have occurred during the years, and these were only two of the more recent ones. The takeoff configuration warning horn is a safety net designed to catch pilots' failure to configure the aircraft for takeoff. It is no replacement, of course, for solid and consistent flow and checklist procedures. Both visual and oral warnings of landing gear position are provided. The landing gear indicator lights provide a visual indication, while the landing gear warning horn is the oral cue. There are 6 landing gear indicator lights on the landing gear panel, a red and a green light for each gear strut. The red lights illuminate under 2 conditions. If the position of the landing gear is in disagreement with the position of the landing gear lever, or if the aircraft is below 800 feet, the thrust levers have been brought back behind the 44-degree position, and the landing gear is not down and locked. The red lights extinguish with either the gear up and locked and the lever up or off, or the landing gear down and locked with the gear lever in the down position. The green lights illuminate when the related landing gear is down and locked. The green lights extinguish when the landing gear is not down and locked. There is an auxiliary set of lights on the aft overhead panel that illuminate green when the landing gear is down and locked. The nose, left, and right main gear each have 2 systems to determine gear position. The primary gear indications on the forward panel use System 1, while the auxiliary indications on the aft overhead panel use System 2. Either green indication for each of the landing gear struts confirms that the corresponding gear is down and locked. The oral landing gear configuration warning is a continuous horn. The onset of the horn is a function of flap lever position, thrust lever position, and radio altitude. There are 4 sets of conditions which trigger the landing gear configuration warning horn. With flaps set from 0 to 10, thrust levers below approximately 20 degrees thrust lever angle, and radio altitude between 200 and 800 feet, the horn will sound but can be silenced by pushing the horn cutout switch on the control stand. With flaps set from 0 to 10, thrust levers below approximately 20 degrees thrust lever angle, and radio altitude below 200 feet, the horn will sound and cannot be silenced. With flaps set from 10 to 15 and thrust levers below approximately 20 degrees thrust lever angle, the horn will sound regardless of radio altitude and cannot be silenced. With flaps set beyond 25, the horn will sound regardless of thrust lever angle and radio altitude and cannot be silenced. With only one engine operating, the thrust lever angle range expands to below 34 degrees on the live thrust lever for the configuration horn. This compensates for the higher thrust settings needed on approach with an engine out. The horn will cut out automatically when the landing gear is deployed. Coupled with GPWS Mode 4A, too low gear alerts, the aircraft will give every warning it can to make sure you don't land with the gear up. Nonetheless, verifying 3 greens is of course essential during the approach. There are many hundreds of controls and indications on the 737 Next Generation flight deck. The master caution system on the NG has changed little, aesthetically at least, since those installed in the original 737s of the 1960s. It is considerably behind modern systems such as ICAS and ECAM, but nonetheless it does an effective job of directing crew attention to problem areas and should be intimately understood. In this lesson we covered an overview of the caution and warning philosophy on the 737 Next Generation, the master caution system, the Mach airspeed warning system, the stall warning system, and we finished with coverage of the various aircraft configuration warnings and the PSEU.